Most of us have used AI-enabled chats like ChatGPT. They are generally very good, but the answers they provide are very general. If you want them to answer questions with our specific documents, policies, manuals, etc., we can do that using RAG-enabled chats. RAG, or Retrieval Augmented Chat, is the technique where we supplement the prompt or question we ask to the chat with our specific documentation so that it can use that as a context and provide more grounded responses or responses more specific to our company policies or documentation. In this project, which I have broken in two parts, in the first part we will build the upload page to upload the documentation to a vector database using Spring Boot and free LLM models. In the second part, we will build a chat interface which will use this vector database as a context source to answer the user questions. Let me first take you through the architecture of our solution. The first step would be where we gather our documentation, policies, etc., and using an embedding model, we convert it to vector representation and store it in a vector database. Next, when the user issues a query, we convert the query again using the embedding model in a vector representation and then do a semantic search or similarity search with that against the vector database where we have uploaded our documentation. Based on the search, the vector database will return a set of documents related to our query. So say if the query is to ask for the number of days we accept returns in our company, it will find our return policy document and return it back. Next, the query and the related document, so our return policy in the example, will be passed to the chat's large language model, which will use those to provide a specific answer to the user. We'd be using Ollama, which is an open source tool that allows users to run large language models locally on their computer, providing an alternate to the cloud-based services like ChatGPT. There are several models you can use with Ollama for embedding. We will use BGE M3 model, which can support 100 languages and can handle various input lengths from short sentences to long documents of up to 8,192 tokens. For the LLM model, we will use Gemma 3N E2B, primarily because it is smaller in size and I can run it on my laptop. Feel free to use any other model you like. For the vector database, we will use the postgres pgvector database. We will build an upload page using which we can upload the documents in the vector database, and then a chat page using which the user can issue a query and get the results. Alright, so it should be an exciting project. Let's get started. First, let me go to start.spring.io. It is a Java Maven project. Let's give the artifact name as RAG. Let me add dependency for web, timeleaf, pgvector vector database, and Ollama. Click generate and save the zip file. Here is a zip file in the downloads folder. Let me unzip it. And here is the project structure. I have IntelliJ open here. Let me click open and choose the pom.xml file of the unzipped project. Open as project. Load it as a Maven project. Here is the pom.xml file where we can see the dependencies for timeleaf, web, AI Advisors Vector Store, Ollama, and pgvector store. And here is the main application class. Now, let's first launch the Docker container for pgvector. Here is the Docker compose file where we specify the Postgres image to use. pgvector, we define the user, password, and DB name as environment variables, map port 5432 inside the container to the same port outside, and the volume. Here, I have the terminal open at the folder where we have the Docker compose file. Let me type docker compose up -d, and it starts pulling the image and then runs the pgvector database. Typing docker ps, we can see the running container. Let me clear the terminal. Now, let's pull and run the Ollama image. Let me type docker run -d -p 11434 :11434 -name Ollama Ollama/Ollama. It does not find the image locally, so it starts pulling it. And then it starts the container. Docker PS now shows both the running containers Olama and pgvector.db. Let's type docker exec -it for interactive Olama bash to interactively enter the bash script of the running Olama container. Let's type Olama pull bge-m3 to pull our embedding model. And for the chat, pull the Gemma 3n E2B model. We can also look at the running containers in Docker Desktop. If you want to learn more about Docker Desktop, watch my video, Docker Desktop Decoded, Simplifying Container Management. We see the two we downloaded here. And here we can see the running containers for Olama and pgvector. We can also interact with the containers right here. So let's click on the three dots here and choose Open in Terminal, and we are inside the container. Type psql-u user rag user and -d for database ragdb, and we are inside the database. Let me type create extension if not exists vector. The extension exists. Let me create the table to hold the vector embeddings for the uploaded documents. Create table public.documents, id, UUID primary key, content, text not null, metadata JSON B, and embedding vector 1024 not null to store the vector embedding. Alright, done. Back to the project, let me open the application.properties file. Let me paste a few lines here. The first few lines is where we configure Postgres, pointing it to the local instance ragdb running at port 5432 in the Docker container. Then we set the username, password, and the driver. Next, using spring.ai, we specify the Olama embedding.option.model as bge-m3 and chat model as Gemma 3n E2B. Let me take you on a brief detour. Going to the browser and typing Olama models, I see this link. Click it. And here you can see the different models which Olama supports. Here is a Gemma 3 model. And you can see there are different models available to pull from, 270 million parameters, 1 million parameters, etc. And they have different sizes. So pick the size you like based on your computer capacity. Generally, the more the parameters, the bigger the size and the more powerful the model is, but depending on your machine's processing power, it may take more time than the smaller ones. So that is the consideration here. And then there are these embedding models like embedding Gemma, Nomic embed text, etc. So a lot of choices. Explore and pick the ones which suits your need. The next property, spring.ai.vectorstore.pgvector.table-name, points at the table name to store the document vector. This is an optional property, and if we had not specified it, the table name would have been vector_store. The next few properties are Hibernate properties. DDL auto update will create the table if it not exists. Show SQL is true, and we set the dialect to Postgres SQL dialect. Next, let me right click on the package node, create new package called controllers, right click and create new class with the name admin controller. Mark it as a controller. With the request mapping annotation, create /admin mapping. Create a get mapping for /upload. Public string get upload page will return upload.htm. This is a thime leaf page we will create next. So thime leaf expects the HTML templates under source main resources templates folder. Right click, new file upload.htm. Let me copy and paste some code here. It is a simple HTML page with a form with action as /admin/upload. Method is post. Encryption type is multipart form-data. There is input file of type file and input type submit as the upload button. Let's see this page. Go to the main class rag application. Let me run the main class. Going to the browser, let me type http localhost 8080/admin/upload, and we see our simple page here. Clicking choose file, we can pick a file. Let's just pick any file. Click upload and we get an error as we have no post mapping for /admin/upload. Let's do it next. Let me stop the application. Going to the admin controller, create a post mapping for /upload. Public response entity string upload file which takes in request param file of type multipart, variable name file. Create a try block. Let's autowire private rack service rack service. We will implement rack service shortly. Call rack service.saveDocument which takes in the file. We will implement this method soon, and if it is successful, we return responseentity.ok with upload successful message. Create a catch block. In case of a failure, we will return responseentity.status http status.internalservererror.body with text error e.getMessage. Alright, now let's implement the rack service. Under the packages, create new package, call it service, then create a new class rack service, mark it as a service. Let me autowire private vector store which are provided by Spring AI framework because we have the dependencies Spring AI Advisor Vector Store and Spring AI Starter Vector Store pgvector in our pom.xml file. Let me autowire private embedding model which is again provided by Spring AI due to our Olama dependency. Now let's create public void saveDocument method which takes in the multipart file parameter. We create a variable string text which gets the file.getBytes with UTF-8 format. Let's create a variable document of type ai.document which is new document taking in the text. Then we call vectorstore.add list of document which would save the vector embedding of the document to the vector store database in our document table. Let's add a system out println text embedded and stored in pgvector. Let's import the classes. Now let's create a method public float getEmbedding which takes in the text and returns its embedding by calling the embedding model.embed taking in the text. This will be useful later. Click on related problems. Let me import the rack service class. Oh, I have two brackets here. Let me fix that. Rack service class shows an error. Oh, again double brackets. Okay, we are good now. Let's try the upload functionality. Let me go to the rack application class and start the app. Going to the browser to the upload page, choose file, let's say return instructions for our company. Click upload and it is uploaded successfully in the vector store. Going back to our pgvector database, select count star from public.document shows one row, so our document is uploaded. Select star from public.document, we can see the vector embedding, the numerical representation. Now let me add the functionality for the chat interface. Going back to the application, let me stop it. Right click on the controller package, choose new class and call it chat controller. Mark it as a controller. Make a request mapping of /API/chat. Autowire the rack service. Create a get mapping. Public string get upload page returns chat.htm. Let's create this page next. So right click on the templates and choose new file. Call it chat.htm. Let me paste some code here. Essentially it is a page which has a text box to take the user input and a send button. And then there is a JavaScript code here which collects the user input or query and then asynchronously calls /API/chat post endpoint and puts a response on the page. Let's see this page in action. Let me run the application. Go to the browser, open a new tab and then type localhost 8080/API/chat and here we see our chat page. Let me type tell me a good joke and it gives a 405 error that the post call on this endpoint is not allowed as we have not created it yet. Let's do that next. Going back to our project, let's go to the chat controller, stop the application first, create a post mapping, public response entity string chat, which takes in the request body of type chat request, we capture in a variable request. We will implement chat request soon. String answer rack service.handle query, passing in the request.get query. Put the equal sign here. Return response entity.ok, passing in the answer. Let's right click on the package node and choose new package, call it model. Right click, new class, call it chat request. Create a variable private string query. Right click, generate getter and setter. Click OK. Click on related problems and import this class in our chat controller. Now hover over the handle query and choose create method in rack service. Float query embedding equal to get embedding query generates the embedding for the passed in query. List document relevant docs equal to document repository dot search similar, passing in query embedding, comma 5. 5 is the top k parameter. Let's auto-wire document repository, which we will implement soon. Now content is relevant docs.stream.map document get text. Collect joining by new line characters separated by 2 dashes. Now the prompt is the context concatenated by the query, which is then passed to the getResponse method. So we are augmenting our prompt, passing in the relevant documents from our RAG repository as context to the LLM. Let's create the getResponse method next, which is calling our chat_client.prompt user, passing in the prompt.call.content. Let's declare private final chat client, import the class, now instantiate it with constructor rack service chat_client.builder, and then this.chat_client is equal to builder.build. Let's right click on the package node, choose new package, call it repository, right click on it, choose new class, call it document repository, mark it as a repository, private final JDBC template. Let's do a constructor injection for it. Let's implement the search similar method to find similar documents to the prompt query by the user. So public list document search similar, which takes in the float embedding for the query embedding int top k. Let's import the document and the list class. String builder vector string is the new string builder starting with an open square bracket. Next, within a loop running over the embedding query.length, we iterate vector string.append query embedding I. If we haven't reached the end of the query embedding, we will separate them by a comma, space, and then once the loop is over, we'll close the string with the right square bracket. String SQL is select ID content from documents, a table where we have our document repository embeddings stored, order by embedding, open bracket, hash, close bracket, question mark, colon, vector limit question mark. We return the top k documents which match by running the query and return their contents. And we also need to have an angle bracket here. Click on one related problem and import the document repository class. Alright, with this, we are ready with our RAG enabled chat. Let me start the app. Now here is the return instructions document we had uploaded for our product, best headphones ever. The eligibility criteria: returns are accepted within 30 days and headphones in original unused condition. Going to the chat, let me type what is the return criteria for best headphones ever. This might take a minute or two based on the processing power of your machine. Again, this is a place where you can experiment with other models to see if there is one smaller and more efficient. Alright, here are the results back, which are what we were expecting. So the chat was able to refer to our document and give us the results back. Cool. So in this video, we first created a document upload page to store the vector embeddings of our company documentation in a pgvector RAG database, and then created a chat interface where a user can ask a question and the chat uses the RAG database to pull relevant documents, pass it in the prompt to the LLM, and returns the answer. Thanks for watching.